Another day, another dead PS5. Hello and welcome back to my workbench. It is time once again to fix something. Today on the workbench I've got another dead PS5 here. This is a 1215 edition, I believe. So the last of the fat models. And I believe this is a no power. I think that's right. I'll put the description on the screen. Let's find out how no power it is. I'm going to give it some AC input voltage. And I think I saw a dip over there. So our power supply is working. At least it's trying to start. So do we do anything? Nothing on power. Nothing on eject. Yeah, that's plenty of time for something to have responded. So yeah, that's pretty dead. All right, let's get the covers off. And as we can see, it has already been opened. Wrong screw. Very much the wrong screw. Wrong screw. All right, this board is out, and I've been just looking over it, looking for signs of work, and I have found some in one particular area around the South Bridge. Don't really see any other kind of work, but I think I know why this board is dead, because I've had this exact same issue recently, and it took me a while to figure it out the first time I saw it. So now I'm kind of looking for it. This is a EDM 033, and let me look under the microscope just a second and show you what I found. All right. There is our flash memory IC, or NOR IC as we call it sometimes, and it has definitely been removed. And I'm not really sure if that one pin over here is soldered or not. It's kind of, it may be soldered a little, but it's definitely been removed. So somebody's been messing with the contents of the NOR, and also looking up under the edge of the South Bridge. If you can tell, it has been changed. There's flux up under it. So that has been changed. And it may be down properly, but she's still rather dead. Let me show you though. This is an EDM 033 board, as you can see there. But the South Bridge that is installed is a, get the light just right, 61GG. Now, most of these boards, if not all of these 33s, definitely the majority of them that I've seen, they come with a 69GG installed. So I think someone has tried to replace a dead South Bridge, and it went from a 69 into 61. And maybe they even swapped out the contents of this. What you have to do, you have to make this be basically you have the correct firmware for a 69GG. It's not the same as a 61, so you have to swap that out. But there's one more step you have to do, and I don't think they have done it. You have to move a jumper right here on the back side. Trying to make sure I keep it in focus. This right here is a 0-ohm jumper, and you can see this other position right here. This is 3.3 volts going in through this jumper into the South Bridge. And right now, I have a feeling it's going to ground because that pad is grounded on this 61GG. It's not on the 69GG. On the 69, it needs this 3.3. So basically, I think we need to move this jumper, this resistor jumper, to ground. Or you could remove it because it's already grounded and going into the chip. But probably the right thing to do is just to go ahead and move it to this position, which would then ground that connection. Because if I show you, let me switch to the other side, where our RT5126 resides. Let me find it and get it in focus. Just a moment. Right here is our RT5126, which makes, the standby voltages for the south bridge. And if we check right now, I'm going to be in continuity mode. Checking to ground. If we check this on this coil here, coming out, that should be the 3.3 out. 0 ohms. It's shorted to ground. And I'll bet you if we move that 0 ohm jumper, that short will go away. And our south bridge may start to work. It may not, though, depending on what they've done to this NOR, if that's the right contents. So yeah, someone's been way into it. And I've seen this exact situation before with that shorted 3.3 volt rail. It just took me a lot longer the last time to figure it out what had happened. But something to look for on these 30 series boards. The 69GG is more expensive, a little harder to come by, but you can replace it with a 61GG. You just can't just swap it and expect it to work. There's some other steps involved. So let's see if we can go ahead and move that jumper. Where is it? I've lost my place. Here we are. Right there. See if we can move that jumper to the other position and see what happens. I'm going to say our short on the 3.3 volt rail will go away. But I don't know if it's going to work after that, but it's a starting point. I'm going to add a little leaded solder to this. All right, is our short gone at the RT5126 3.3 volt output? Back in continuity mode, black probe on ground. Yes, our short is gone. All right, let's give this board 12 volts and see if it tries to initialize or not. Or, do we have to do something with the contents of this flash memory IC? Or possibly with this south bridge. So let me get set up for that. We'll get 12 volts into this board. Well, I think I'm set up. Positive lead on the positive contact. And let's see, yep. 12 volts, half amp current limiting over here. Let's give it some power. Okay. Well, we don't have a short now, but we're still pretty dead. So I have a feeling the contents of that NOR are not correct. And that's fine. I'm hoping that's the original contents because we can fix that. Yeah, 3 milliamps. Let's look at something. Let me get set up with the scope, and I want to see if this south bridge is at least trying to access this chip or not. Probably is. May also have to look at that pin that looks like it's not quite making contact. Okay, back under the microscope for just a moment. Looking at this is pin 1, 2, 3, 4, 5, 6. Let's move it, nudge it a little. Yeah. Can you see it moving? She's not making contact. So let's touch that up before we go messing with the contents of the chip. I think that's the only one that Needs a little extra solder on it. There we go. All right. Now let's give the board 12 volts and see if it makes any difference. All right. Back to giving it 12 volts. What does it do? Still 3 milliamps. Okay. Maybe time to break out the scope. Let me crank it up over here. Might look at a few things before I take this chip off. Just want to see if our south bridge is totally dead or doing anything. All right, we're going to make a quick check behind the south bridge here on this 32 kilohertz crystal, just to see if it is indeed running, because there is a lot of flux up under this south bridge. So I'm going to get on one of these contacts here at the crystal. And yes, I would say it is running. 32.768. She is exactly on frequency and working just fine. So that's not the issue. Let's make a quick check then to the other side of the board at this NOR chip right here. Let me give the board 12 volts. I'm going to connect the wires. I'm not going to turn on the supply yet. And try to get my scope set up for DC. And not quite so much sensitivity there. And I want to see if we're getting some activity. We can get on these resistors right here, I think. When we give it 12 volts, let's see what happens. I didn't see anything happen. Nope, not even the slightest hint of activity. Let's see. Trying to remember which pin is the... Let me make sure I'm getting my 3.3 volts, which is what powers this IC, NOR. Let me check right here. No. I'm on that test point. Do we have... Okay, do we have a blown fuse? We have 5 volts there. Yeah, we've blown the fuse. Something has blown the fuse. So now I'm wondering, are we getting back to some original problem that this board had? Let me turn off the 12 volts. Go to resistance mode, or continuity mode. Do we have a short? No, we don't have a short. 3 k ohms. So how did they manage to blow that fuse is what I'm wondering. We're not shorted. And we had 5 volts on the input side. All right, power supply is off. Let me grab a fuse. Let me look at my notes. I think that's a 5 amp fuse. All right, that is F7003. F7003 is a 5 amp. Just wanted to make sure. All right, let's see if we can get some 3.3 volts now. I think we can. Let's see. All right. Let me get right on this point. Slide that up a little. Right about there. Well, we went to 10 milliamps then. And we are getting 3.3. We are getting 1.15. Do we have, we don't have 3.3 there. We're going to need that. Do we have 2.0 up here? We do. And a 1.8 right in here somewhere. Yep, that's good. So, now are we getting any activity, I wonder? We should have, yeah, 3.3 now down here on this NOR IC. We're making progress. We're still drawing, it's just hanging at 10 milliamps on the power supply, so we're not initializing it anyway. So if I get on one of these resistors here, the DC level goes off the chart. Just a moment. There we go. Now if I turn this off and we'll give it 12 volts again, yeah, you see a little burst of data there? I'll do it again. Yeah, that's data. That is the south bridge trying to access this NOR IC. And let me try that. I don't see any activity on it. When it sees, you know, when it gets the data, apparently it cannot execute it. So it just sits there. Yep, I don't think it likes the contents of that IC. So that is going to be our next step, probably. We really don't know the history of this, of what's on here. If this is a, you know, if this is the original contents, that'd be great. Because we could convert that over to a 69GG. If it's not, then we gotta just get creative. Okay. I think let's get this chip off and see what's on this chip. Okay, and I'm going to clean this chip off, clean the legs off so I can get it in my holder, little grabber. And it doesn't seem to, the grabber doesn't seem to like it if the legs aren't clean. Does not make contact reliably. So we'll do that, clean it up. We'll be ready to read the contents of it. See if I can fit it into this adapter. Get pin 1 turned the right way. Yep. Something like that. And maybe that will read. All right, so I have dumped the contents of this NOR chip 3 times, and you'll see it labeled temp and temp 1 and temp 2. These are 3 copies of the same file. Dumped 3 different times, trying to make sure I've got a good copy of the contents of that NOR IC. And I'm going to be using PS5 Wii tools to analyze this and hopefully correct any issues. So let me pick file 10 here. And here we can see the details about that particular dump or contents of it. And what I need to do, looking at this serial number here, that serial number does match what's on the case of this computer, of this PS5. So I'm hoping this is the original one. The original MAC addresses, everything. Serial number should match. So what we need to do, though, is this is going to be for a 69GG. We need the firmware for a 61GG. So what I'm going to do is I've got it selected. I am going to pick option 2 and extract that flash dump and break it down into its base files. These are the files that make it up. It has now created a folder with the serial number of this PS5 as a folder name, so we can get in there and find it. And if you look in here, you see this EMC IPL-A and EMC IPL-B. That, my understanding is that's the actual firmware for the South Bridge. So what we're going to do is we're going to replace that. I know I already have on here a donor that I have used before. So let me see if I can browse there. If I go to, well, I can go over here, sorry, PS5 Wii Tools, you'll see this folder that's been created today. And you'll see these files in there. And there's a EMC IPL-A, EMC IPL-B. So let me go back. Let me go into this donor folder. This is something I extracted previously. And I know this is from a working 61 based board, 61GG based board. I think it may be a 10 series. Don't think that's going to matter. So I want to copy. I'm going to select these 2 files in this donor this is something I previously extracted from a working firmware for a 61GG board. And I'm going to copy those. And I'm going to go back over into that folder that we just extracted earlier. And I'm going to overwrite these 2 files. Replace. So now we've replaced those 2 files. Now go back to PS5 Wii Tools, and I want to build a dump from the extracted files, option 3. And it has gone into that same folder and made it a one solid file again, labeled called s/0.bin. So it's taken all these files, including the ones we replaced, and built it back into a single file. So we should now have a file called s/0.bin in that folder. Yes, right there it is. Now we're going to go into XG Pro. We're going to load that. Let's see, where is it? Right in here. S/0, open. Okay. And that does not look right. Oh, I see what I've done. s/0.txt. That is not the right file. Let me say load. Let me go back in here. s/0. I grabbed the text file, which is describing what's in there. s/0. I wanted to get the actual bin file. Let's try that one. There we go. That looks much better. Now, we will program that to our original IC here. We have good backups if we need them. Still got 2 other copies that I haven't messed with at all. That should be, good. But I'm going to say program. And we're going to program that back to our chip. And it should verify it as well. And we are done. All we got to do is reinstall this chip, and let's see what happens. We'll put it back on the board and see if we get a reasonable looking initialization on this board now. Okay, the moment of truth. We have reinstalled our flash IC here. Let's just see if we can get anything close to a normal initialization. I'm going to give it 12 volts at half an amp. And hopefully she'll go up to, no, 34 milliamps. Do we have another problem? She tried, oh, no, it's going to 300 milliamps. Come back down. I think I've seen that before after swapping this out. Let me turn this off and back on. And I bet you this time it goes straight to 300 milliamps. Oops, I double clutched on the button. Try it again. 300 milliamps and come back down. There's some kind of a rebuild process or something that goes on after I've done this. It should be fine though. I think we're working. Let me get it back in the chassis and let's just see if we can get a picture out of this thing. Maybe. Let me clean up some liquid metal and get rid of that dry spot too though. I'll do that off camera. All right, so I got this PS5 over on the test bench. I think we're ready to see if she will now turn on. The basic cable's connected, the fan's connected, power, HDMI. Fan spin, where's the blue light? Maybe we got a bad ribbon cable for the LEDs or something. Because we have picture. I can't believe. All right, we're starting up. That's looking good. I'm going to guess that if I check these contacts on this ribbon connector right here, they're probably folded over. It's pretty common. It's rebuilding the database. Yeah, probably because of the work I've done on the NOR. Maybe. But we're turning on. Excellent. Okay, let me figure out what's up with, oh, no, so part of the ribbon is working. The white LED is working. The blue is not working. Probably a folded over contact, so, but that's looking promising. All right then, our blue LED is not working. And first thing I did was take a look at this ribbon cable, and it looks perfectly fine. I don't see any obvious problems there. So I did try an entire new ribbon cable and board assembly, which I know is good, and still no blue LED. So that points to a problem on the board. And if I can show you, I believe if we look at this connector that this ribbon cable plugs into, I'm in diode mode. Pin 4 is the PWM signal for that blue LED right in there. This is pin 1, 2, 3, 4. We get a reading, 0.51, similar to the other LED drive signals, like there and there. So pin 4 is connected to something. The ribbon cable is unhooked right now. It's not the ribbon cable I'm reading. I'm reading back all the way to the south bridge. So it's not like it's not connected under the south bridge. It's connected. It's just not working. And everything else seems to work. The other PWM signals for the LEDs, you know, the amber and the white, and then you got a PWM signal for the a PWM for the fan. That all works. So that kind of makes me think that south bridge is not good. At least that particular output is not good. So I have gone ahead and reballed another 61GG, and we are going to replace it. and see if that fixes our blue LED. Well, the board is back in the chassis. I've got the fan connected. I've got the ribbon cables connected, including the LED. Let's see. I'm going to give it some power. Power supply started. Let's give it a moment to initialize. Let's see if we get a blue light. I really hope we do. And here we go. Blue light. Never thought I'd be so happy to see a blue light. So apparently it was that south bridge. Good. All right, I think I'm ready. That white light. We should be ready to put this all back together and give it a full test out, install a game, and make sure everything works. Let me do that. Actually, not so fast. I almost forgot. This board is missing a USB port. One of the rear USB ports is missing, and I had forgotten about that. It was. It looks like somebody's just been, salvaging parts off this board. So I'm going to go ahead and install a new port there, and I think I am going to go ahead and change out the HDMI port, simply because during some testing I noticed it was a little bit intermittent. Looks to be an original port. I'm not sure. Soldering looks to be factory. So I'm going to swap that port out and put a new USB port on the rear. Then we should be ready for a test out. Well, this PS5 has been fully reassembled, and when I first tried to load a game into it, the Blu-ray drive would not load a disc. Uh, you could attempting to insert a disc would turn the console on, but it would not pull the disc in. And fuse F5402 was blown. The 12 volts into the Blu-ray drive was actually, the fuse was blown. So I did get that replaced, and after that, no more problems. I've installed a game and letting it run in demo mode, and yeah, looks good. Well, anyway, I hope you liked that one. I thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.